All our life, we had been told to use soap before eating, going to the bathroom, and more. And we all have soap lying around the house, right? It is something that is extremely easy to overlook and one that is not given much thought into, that is, until we run out. There are different kinds of soap: laundry soap, body wash, and dishwash. But how does it work really effectively? Soap, made from animal fats, wood ash, and water, was first produced by the ancient Babylonians all the way back to 2800 BC. They were made first to wash wool and cotton in order to prepare them to be woven to cloth. Back then, soap was not necessarily used to wash the body. However, the ingredients for making soap still remained the same up until now: the basic use of fats and oils. Now, soaps are produced from the hydrolysis of fats in a chemical reaction called saponification. Saponification is the alkaline hydrolysis of fatty acid esters. Triglycerides were reacted with sodium or potassium hydroxide to form a mixture of glycerol and a fatty acid salt, which we call soap. Sodium hydroxide produces hard soap, while potassium hydroxide results in soft soap. We can see the three-step mechanism of saponification. Step 1 is the nucleophilic attack by the hydroxide. Step 2 is the leaving group removal. The last step is the deprotonation. Oil and water do not mix right. But what happens when we add soap to it? Here, inside is a glass of water. And now let's add this portion of oil. And mix it. We can see that oil and water are separated in two different layers. With 2 pumps of soap, let's mix it again. There, we can see that there are no separating layers, indicating that soap is an emulsifier, capable to disperse one liquid to another immiscible liquid. But how does this work? Each soap molecule has a carboxylate head that is negatively charged, a polar molecule, and hydrophilic, which means it bonds with water through ion dipole bond and hydrogen bond. At the other end, they have a hydrocarbon tail that is a long chain, non-polar, and is hydrophobic, which means it avoids water and bonds with oil and fat instead. This is what happens when you wash your hands. Before, the dirt and soap molecules will not interact with each other, but once mixed with water, the hydrophobic end tries to stay away from the water by forming tiny clusters called micelles, with the hydrophilic end pointing outwards that form the outer surface. The dirt and oil on our hands would then be suspended in the water and get attracted to the inside of the micelles, which would get trapped, making it easier to be washed away. Now we know how soap works and how it can clean dirt off of our body. So thank you for watching.